All right. We got Algebra 2, Lecture 1020, 1021, OSA 2A14. The student will solve quadratic equations. Again, we're doing quadratic equations by isolating the variable, just like we did in the last lecture, including positive and negative imaginary solutions. We're going to be introduced today to the idea of imaginary numbers. They're based on the idea of trying to take the square root of a negative value. Think about it. If you take the square root of a negative 16, for instance, you would ask yourself, well, what number could I multiply by itself that would give me negative 16? And you would try, well, 4 times 4 is not negative 16. Negative 4 times negative 4, that's still not negative 16. And so if you think about it, of all the numbers we're aware of, if we multiply any number by itself, we'll never get negative 16 because any number multiplied by itself will always yield a non-negative result, because negative times negative is positive. So we needed to find a way to take square roots of negative values, and so we invented the imaginary numbers or the imaginary solutions. And it's based on the idea of the imaginary unit, and here's what it looks like. The imaginary unit is the number I, and that is defined as the square root of negative 1. So wherever you see the square root of negative 1, you can write the letter I, and they're equal in value. I times I will give me negative 1. It's the imaginary unit, and that's the basis of the imaginary numbers and the complex numbers, which we'll talk about later. Today we're just doing imaginary, and that's going to be the basis of what we're doing. Wherever we see an I, we know it's the square root of negative 1. Wherever I see the square root of negative 1, I'm going to call it I. So here we go. Otherwise, we're going to treat everything just the way we always have. But when we see the square root of negative 1, it's going to be I. Here we go. If I was asked to find the square root of negative 4, you could try to find that with your calculator if you would. And your calculator would tell you error or domain error or something along those lines. It will take the square root of a negative because there is no real number such that if I multiply it by itself, I'll get negative 4. However, there are imaginary solutions, and here's how that would work. I can think of the square root of negative 4, I can think of it as the square root of negative 1 times 4. And I know the square root of negative 1, by definition, is I. So I'm going to pull this out from under the radical, so to speak. I'm going to think of this as the square root of negative 1 times the square root of 4. Square root of negative 1 times the square root of 4. You can think of this as this. The square root of negative 1, by definition, is I. And the square root of 4 is 2. And usually we put the real number first and just call that 2i. So the square root of negative 4 is 2i. That means if I multiply 2i times 2i, I'll get negative 4. And I will. If I is equal to the square root of negative 1, then I squared is negative 1. It's the only number that I can multiply by itself that will give me a negative value. And we invented it so we could take the square root of negative numbers and solve some problems in physics and whatnot. Here we go. We're going to take the square root of a negative 36. So I'm going to think of it as the square root of negative 1 times 36. Negative 36 is negative 1 times 36. So I'm going to think of this as the square root of negative 1 times the square root of 36. Square root of negative 1, by definition, is I. Square root of 36 is 6. I times 6, we usually write it as 6i. There's our square root of negative 36. Let's take a look at this one, the square root of negative 23. I can think of it like this. Then I can also think of it like this. You don't have to actually show this part, but you can think of it like that and say, well, that's I. By definition, square root of negative 1 is I. Square root of 23 won't come out from under the radical. I radical 23. I leave my answer like this with the I on the left so it doesn't look like it's under the radical. But if you want to put your radical first, that's fine. Just make sure that the I doesn't look like it's under the radical. Don't make this radical symbol so long that the I looks like it's under there with it. It's not. Whoops. if you're going to put your I on the right side of the radical, make sure that it's not under the radical. Okay? I prefer writing it like this. So there we go. That's the type of thinking we're going to be using to solve quadratic equations, including imaginary solutions. So here we go. We're going to solve some equations, see what it looks like. Solve by taking the square roots. I've got m squared is equal to negative 15. So I'm looking for some number that I can multiply by itself that will give me negative 15, and there is no real solution to that. So we'll go into the imaginary numbers. I'm going to take the square root of both sides. This is m is equal to, I can think of this as the square root of negative 1 times the square root of 15. I can think of it that way. That's I. That's the square root of 15. It won't come out from under the radical, so I'll just leave it under the radical. And don't forget, as we did in the last lecture, there are two possible roots here, a positive and a negative value. So the n equals plus or minus I radical 15. That's how I personally would write the answer. You can see it written like this in the standard test, standardized test. Or you might see it like this. Again, if you're going to put the I on the right side of your radical symbol, just be careful that it doesn't look like it's under the radical symbol. Okay? Any of these is an appropriate way of writing the response to that. And let me get my answer sheet and see if I got that right. Yay, I radical 15. So let's take a look at this one. I'm going to take the square root of both sides. Again, I'm looking for a number I can multiply by itself that will give me negative 36, and there is no such real number, so we go to the imaginary numbers. And I think of this as P equals, and I think of this as the square root of negative 1 times the square root of 36. Well, the square root of negative 1, by definition, is I. The square root of 36 is 6, and we got to include the positive and negative roots. So, plus or minus I6, when it's not a radical, it's an integer, we often just put the integer first, plus or minus 6i. And you can look at it like this, or look for it like this in a standardized test, or you can look for it like this in a standardized test. Any of these three is an appropriate way to list the solutions to this original equation right here. We couldn't find a real number that we could multiply by itself that would give us negative 36, so we found an imaginary solution, two imaginary solutions. Okay? Imaginary numbers, this is your introduction. Here we go, I want to isolate my r squared, so I'm going to divide by negative 3. R squared is equal to negative 14. Let me go ahead and show that. I just divided by negative 3. That gives me this. Now I'm going to take the square root of both sides of my equation. R is equal to, I'm going to put my plus or minus here because I just took the square root of both sides of an equation. Plus or minus, I'm going to think of this as the square root of negative 1 times the square root of 14. That's I, square root of 14. 14 won't come out from under the radical. It's not a perfect square, so I'm just going to rewrite it radical 14, or square root of 14. However, this will be plus or minus I. 14 will stay under the square root symbol, or under the radical, and there's our solutions. There are two of them. You could write your answer like this. You could expect to see it in a standardized test like this, or like this, or like this. And again, it doesn't matter. The order in a set, the order of the solutions in a set doesn't matter. The negative one can come first. Any of these is a correct way of listing the solutions to that equation. Let's take a look at this one. Negative 3a squared is equal to 90. I'm going to divide both sides by negative 3. A squared is equal to negative 30. Take the square root of both sides. A is equal to plus or minus the square root of negative 30. I'm going to think of as the square root of negative 1 times the square root of 30. That's I times the square root of 30. And that won't come out from under the radical either. So A is equal to plus or minus I radical 30. And again, we could write those or expect to see them written like this in a standardized test. Or like this. Any of those three is an appropriate way of stating the responses to the original equation. And let me check to see if I got those right. Proceeding over through the following. Plus or minus I radical 14, yay. And plus or minus I radical 30, yay. We're gonna roll. See if I got two more examples. Here we go. I want to isolate b squared, so I'm going to subtract 6 from both sides and then divide by 9. That's my plan. Then I'll take the square root of both sides, and if I have to, I'll include imaginary solutions. So here we go. Subtracting 6 from both sides, 9b squared is equal to negative 28. Dividing both sides by 9, b squared is equal to 28 over 9, negative 28 over 9. Taking the square root of both sides is going to give me b is equal to plus or minus the square root of negative 28 over 9. Well, that minus sign, I'm just going to pull that out now. I've been telling you all, I'll think of that as the square root of negative 1. Another way I can think of it is say, well, I know this minus sign is going to come out as an I. So there it is. The square root of 28 is the square root of 28. The square root of 9 is 3. And you know what? There's a perfect square in there too. If you take the square root of 28 with your calculator, that will give you 2 radical 7. So this would equal plus or minus I times 2 radical 7 over 3. And it will usually, most of the time, that will be written like this. Plus or minus 2I radical 7. That's how they'll write it. They'll put the I up here, just on the other side of the 2. Over 3. This isn't wrong, but it's usually written like this. And in a standardized setting, we can expect to see it written like this. Or like this. All three of these are correct, unless I've made a mistake. Let me see if I got it wrong. 2I radical 7 over 3 and negative 2I radical 7 over 3, yay. At this point, if you did this with your calculator very carefully, your calculator, don't put the minus sign under there. Just remember there's going to be an I there, and do the 28 over 9 with your calculator. It'll tell you 2 radical 7 over 3. But don't forget your I. You got to pull that I out first, because your calculator won't take the square root of a negative. It'll tell you domain error. So pull that out as an I, and then you can take the square root of 28 over 9, just the way it looks, with your calculator, and it'll tell you 2 radical 7 over 3. I'm going to try to move this stuff over a little bit. Oops. Give myself some room over on the left. All right, here's the last one. I'm going to come up with my game plan. I'm going to add 9 to both sides. I'm going to divide both sides by 3. Then I'm going to take the square root of both sides. Remember my positive or negative imaginary roots. Here we go. Adding 9 to both sides. 3p squared is equal to 22 minus 9 is what? 13. and that will be negative. And then I take this, I divide both sides by 3. Take the square root of both sides. Rewrite this. Take the square root of both sides. This will give me P is equal to plus or minus the square root of 13 over 3. And if you do that with your calculator, it will tell us the positive or negative. Oh, I forgot my I. I pulled my I out and I forgot to write it down. We got in a hurry. I'm going to take the square root of negative 1. This is negative 1 times 13 thirds. Square root of negative 1 is I. And now the square root of 13 thirds, if I do 13, if I pull that out and I take the square root of 13 thirds with a calculator, it'll tell me radical 39 over 3. I'm nearly certain. And that will be written as usually P equals plus or minus I radical 39 over 3 if I haven't made a mistake. I'm going to check that before I go any further. Yay! And you can write that like this, or expect to see it like this. Or you could expect to see it like this in a standardized test. And you could also stick the I out to the side if you wanted to, or out to this side. But usually it's written like that. And I believe, yeah, I already checked it, and those are correct. So yay, that's how we handle taking the square root of a negative value, and we're doing that within the context of solving quadratic equations. And if our quadratic equation winds up such that we have to take the square root of a negative value, we now have the tools to do that by remembering that negative 15 means negative 1 times 15. And the square root of negative 1 by definition is I. And then the rest of it's just regular old radicals. You can do this.